Hello, and thank you for joining the session on how to optimize workloads for sustainability using AWS Graviton-based EC2 instances. My name is Zishan Lim, and I lead sustainability go-to-market for Graviton in the AWS Worldwide Specialist Organization. In my role, I help AWS customers and partners achieve their business and sustainability objectives.
Thanks, Z. And I'm Chad Schmutzer. I'm a sustainability solutions architect focused on Graviton. I'm also in the same organization as Z, and we work together to help support customers on their journey to sustainability. Back to you, Z.
So the greenest energy is the energy we don't use. I'd like you to keep this quote in mind as we go through today's session. What can you do to achieve your mission or grow your business without increasing resource consumption? How can you do more with less in today's climate, economically and environmentally? In this session, we'll first have a quick overview of Graviton and how AWS designed Graviton for energy efficiency. We'll dive deeper into the strategy of how customers can reduce the environmental impact of their workloads running on Amazon EC2 instances. Throughout the session, we'll be sharing real-world examples of how Graviton customers are reducing the carbon footprint of their workloads while also achieving better performance and cost efficiencies. We'll also be sharing the various resources you can leverage to get started with your Graviton journey. So, why Graviton? What has motivated over 40,000 customers, including 48 of the top 50 EC2 customers, to adopt Graviton? With AWS Graviton, customers are achieving the best price performance for a broad range of their cloud workloads. Customers are also achieving significant cost savings. And along with better performance and cost, Graviton instances are also more energy efficient, which enables customers to lower the carbon footprint of their workloads. AWS Graviton processors are custom designed by AWS to offer the best price performance in Amazon EC2. Graviton processors include ARM-based processor cores and are optimized for cloud-native workloads. By innovating at the silicon or chip level, AWS can build and iterate on behalf of customers to help them achieve better performance at a lower cost for their cloud workloads. Graviton family of processors is currently in its third generation. Due to innovations enabled at the chip level, Graviton tree-based instances offer significant generation over generation performance efficiency improvements, from the 25% better general purpose compute performance to up to 3 times better machine learning performance, and the introduction of new energy efficient technologies such as DDR5 memory. These are all examples of the rapid innovation enabled by Graviton to AWS customers. With end-to-end ownership, AWS also innovated at the server level with the goal to better balance the space and power consumed at each server rack in the data center. With Graviton tree servers, AWS designed the chip, package, and motherboard to fit 3 processors per server. This leads to a more efficient solution overall and improved utilization of shared infrastructure. With the 3 processor design over a traditional 2 processor design, we can host 50% more of these efficient instances with less power for cooling and less space in the data center, which has the follow-on benefits of lower embodied carbon. Let's take a look at a few customer examples of how Graviton is helping accelerate their sustainability goals. Amazon is an example of a large enterprise adopting Graviton to meet environmental sustainability goals and the climate pledge. Inside Amazon, teams have migrated and are migrating their workloads to Graviton to save on energy and also to save on cost. For Prime Day 2021, Amazon increased the amount of compute usage by 12.5%, but due to better efficiencies of Graviton, actually used 6,000 fewer servers to support this peak event. One specific example of a large-scale production workload is the data path service that powers the Amazon.com site. During Prime Day 2021, this workload ran on a 3-region cluster with over 53,000 Graviton instances. The performance efficiencies of Graviton at scale means Amazon reduced the carbon footprint of the workload running on one of the busiest times of the year. The cost savings due to better price performance of Graviton enable Amazon to reduce on costs and pass on those cost savings to customers. Graviton enable better performance, lower carbon footprint, and lower cost. For Prime Day 2022, Amazon increased the total compute usage by 12%. However, thanks to the increased adoption of the efficient Graviton instances, the overall server equivalent footprint was only 7% larger. Customers are also leveraging Graviton to accelerate their sustainability mission and business. They are advancing their sustainability solutions while building them sustainably in the cloud using Graviton. Modern Electron is focused on decarbonizing heat and power, and they chose Graviton to run their simulations. Lightyear, a pioneer in solar electric vehicle, leveraged Graviton for the compute-intensive vehicle design simulations. Siebel Labs, an agricultural data analytics company, leveraged Graviton for their data-intensive satellite imagery processing application. By leveraging Graviton's performance and cost efficiencies, these customers achieve faster time to solution with the same or smaller budget for their compute workload. By using the energy efficiency of Graviton instances, they are aligning operational sustainability with their organization's environmental sustainability goals. Now let's talk about sustainability in the cloud, or how you can reduce your workload's environmental impact in the cloud. Similar to the shared responsibility model for security, there is a shared responsibility model for sustainability. With sustainability off the cloud, AWS designs buildings, rooms, servers, and takes care of it from construction to recycling. AWS purchases energy and ensures that the energy and other resources, such as water for cooling, are used efficiently. And lastly, AWS service teams run managed services and optimize them for sustainability. With sustainability in the cloud, customers are responsible for making architectural decisions for their workloads, improving efficiency of their code, and utilizing cloud resources efficiently. With the sustainability pillar, the sixth pillar of the well-architected framework, customers have a framework to architect and implement their solutions sustainably. In the sustainability pillar, hardware and services is one of those 6 categories of best practices within the sustainability pillar. And diving in, you will see best practices that encourage efficient use of cloud resources and using efficient resources. Some of those recommendations include using instances that are designed for specific classes of workloads. And this leads us to sustainability in the cloud with Graviton, where you have agency and a shared responsibility to choosing efficient instances to use for your cloud workloads. Let's start with EC2. EC2 is typically the largest component of a customer's compute usage and therefore a high impact opportunity to drive efficiencies in terms of resource consumption, cost, and carbon. As of today, we have 18 instance types that are powered by Graviton 2 and Graviton 3, available across all 31 AWS regions. There are over 100 Graviton-based EC2 instances you can choose from. Now, these options enable you greater flexibility in right sizing for a broad range of your workloads. So how are efficient Graviton instances helping customers with sustainability? Here's the strategy. The first way is to reduce the fleet size. Now, due to the better performance with Graviton, customers can use fewer instances while achieving the same workload outcome. The second way, reducing the instance size. Because the workload performs better on Graviton, customers can use smaller instances to deliver the same outcome. And finally, combining these two vectors, you can use fewer and smaller instances to achieve the same workload outcome. Let's walk through a few customer references to see how these strategies are applied in real-world use cases. First, reducing the fleet size of the workload. Snap, known for its popular Snapchat app, migrated their messaging core service to run on Graviton-based instances with EKS. Because of better performance with Graviton, they reduced their fleet size and significantly lowered costs. Better performance, smaller fleet size, less resource consumed leads to lower costs and lower carbon. Second, using smaller instance size for the workload. Sprinkler, a customer experience management platform, migrated their Java workloads to smaller Graviton instances. They benchmarked larger x86-based instances versus smaller Graviton instances and saw similar throughput, with a significant 50% reduction in query latency. The price performance benefits translate to meaningful total cost of ownership reduction for their workload. Better performance, smaller instances translates to less resource consumption, lower carbon, and lower cost. And finally, reducing the fleet size and using smaller instances. CyberAgent is a Japanese internet media services company serving media, internet advertising, and game businesses. They successfully migrated their web services to Graviton instances and achieved up to 60% cost savings through a combination of smaller fleet size and smaller instances while maintaining service performance. Better performance, less resource consumed translates to lower cost and lower carbon. I'll now hand it over to Chad to discuss how you can improve the sustainability of your workloads and getting started with Graviton quickly to leverage the performance, cost, and carbon efficiencies. Over to you, Chad.
Okay, thank you, Z. So let's dive right into learning about getting started with AWS Graviton. So let's first take a few minutes to review the sustainability connection between compute usage and your workload. So Z just went through some examples of how customers reduced their resource consumption relative to the business outcomes of their workloads. Here are a couple ways to think about their carbon savings. The first, workload carbon emissions, which is correlated with their resource consumption. As the customer's business grows and compute usage grows, the workload carbon emissions increase accordingly. The analog of this is workload cost, which is correlated with their compute usage. The second way to think about the carbon savings is workload carbon intensity. This is essentially workload carbon emissions normalized to workload performance. As the productive work per unit compute improves, the workload carbon intensity improves. The analog of this is workload cost efficiency or price performance, which takes into account the workload outcomes or KPIs when measuring costs. These metrics are workload specific. For example, the customer may be tracking queries per day for their data warehouse or bid per second for their advertising platform. Due to better performance on Graviton, customers achieve significantly better price performance for their workloads. They can similarly anticipate a meaningful workload carbon intensity reduction for their workloads on Graviton. Customers are optimizing their costs on AWS and driving cost efficiencies not just to save money, but also unlocking capital to reinvest in innovation for their customers and business. Graviton is one of the biggest levers to helping them achieve their cost efficiency goals, while also supporting their carbon efficiency goals. With Graviton, customers can do more with less. They can achieve better performance, lower cost, and lower carbon, all at once, and it's not a trade-off. So here's an example of an AWS partner who's helping customers reduce their workload carbon intensity. Aerospike provides a NoSQL real-time data platform for their customers. As an AWS partner, Aerospike has enabled their customers to deploy workloads on AWS Graviton. With Graviton, Aerospike delivers the trifecta of better performance, lower cost, and lower carbon. You can read more on their blog published by their founder and CTO. The link is there at the bottom. So here's another example of how AWS partner Snowflake optimized their workload carbon intensity using AWS Graviton. Snowflake provides virtual warehouses for their customers. To support their sustainability goals, Snowflake seamlessly transitioned their virtual warehouses from x86-based instances to instance families based on AWS Graviton processors. This migration helps Snowflake optimize their cloud environment for cost and performance, resulting in a 57% lower workload carbon intensity and 10% better performance. You can learn more about Snowflake's migration to Graviton by checking out the blog referenced here. Okay, now let's jump into getting started with AWS Graviton. So first, let's do a quick level set on how we can determine if an instance type is powered by Graviton. Right, so starting with 6th generation EC2 instance families, this is the instance name breakdown. So you have the instance family, the generation, followed by the processor. And so in this case, the G stands for Graviton. So this is the easiest way to determine if an instance type is powered by a Graviton processor. Following that, you have attributes specific to that instance type, and then you have the instance size. So keeping this in mind, let's take a look at all of the instance types available today powered by Graviton. So I really like this slide because people are often surprised at just how many instance types are powered by Graviton. In fact, as of today, we have 18 instance types powered by Graviton 2 and Graviton 3 available across all 31 AWS regions. So this includes general purpose instances, a burstable instance, and a set of compute optimized, memory optimized, storage optimized, and GPU accelerated instances. If your workloads are running on Linux, whether they're homegrown or based on open source software, you can spin up a Graviton instance and try it out. All major Linux operating systems, the container ecosystem, and many ISV software already support and are optimized for Graviton. And keep in mind, they're available in sizes that range between 1 to 64 vCPUs, allowing greater flexibility in right-sizing a broad range of your workloads, as Z discussed in earlier slides. So Graviton is also supported across a wide range of AWS managed services, making it very easy to get started with Graviton and see the price performance benefits with little to no code changes. Major AWS infrastructure services such as Amazon EKS and ECS support Graviton-based instances to help customers orchestrate, monitor, and secure their instances. Graviton is also supported by serverless services like Lambda and Fargate. In addition to these, Graviton is also available through AWS Managed Database Services, including Aurora, RDS, Elasticache, and MemoryDB, and across Managed Analytics, including OpenSearch and EMR. Last but not least, Amazon SageMaker also supports Graviton 2 and Graviton 3 based machine learning ML instance families, so that customers have more options for optimizing their cost and performance when deploying their ML work models on SageMaker. So when thinking about your very first steps towards migrating to Graviton, start on the path of least resistance. Grab a few easy wins and get them under your belt. Get comfortable and confident. Then move on to the high impact workloads to achieve high return on investment along with greater impact. But keep in mind, these paths are not mutually exclusive. Certainly high impact workloads with lots of compute and large instances running in a low tech debt environment exist. The point is finding the starting point that makes the most sense for your organization. Because remember, the goal is ultimately to do more with less. So here's another view of the path of least resistance broken down by workload and typical workload required actions. So again, highly recommend that you pick a few easy wins and then move on to the highly impactful and sizable workloads. So taking this view into account, let's dive a bit deeper into each of these workload categories. Let's start with Amazon RDS or Aurora. So first, very easy to upgrade. So first thing to do is, if necessary, upgrade the database. So you want to determine if the current database version meets the minimum required version for moving to Graviton. If necessary, upgrade the database engine to the required minimum version. Next, you'll modify the instance type. You'll determine your strategy and the order in which you modify your instances. Then you'll modify the instance class of your instances to the appropriate Graviton instance. And finally, validate and confirm that the application works correctly. So quite easy and a very simple path to migrating to Graviton using Amazon RDS and Aurora. Next, Amazon Document DB. Upgrading an existing Amazon Document DB instance to Graviton requires a simple instance type modification using the same steps as any other instance modification. Your applications will continue to work as normal, and you will not have to port application code. Next up, Amazon Neptune. So upgrading a Neptune DB cluster to Graviton requires a simple instance type modification for Neptune Engine version 1.1.0.0 and higher, using the same steps as any other instance modification. Again, your applications will continue to work as normal, and you will not have to port application code. Next up, Amazon Elasticache. Again, another easy migration to Graviton. In fact, Graviton is the default choice for new clusters when deploying an Amazon Elasticache cluster. But if you need to migrate in an existing environment, what you'll want to do is modify the existing cluster. You can apply that immediately. You can apply that during the next maintenance window, or you can provision a new cluster and point your application at the new cluster. After that, you'll simply allow the cache to stabilize again, and you're on your way. So again, very simple path migrating towards Elasticache with Graviton. So Amazon OpenSearch Service. So what you'll want to do is check again if needed, upgrade the Amazon OpenSearch Service cluster. You'll want to determine if the current cluster version meets the minimum required version, which is 7.9 or later for moving to Graviton. Then you'll upgrade the Amazon OpenSearch Service domain to the required minimum version. Next, modify the instance type of your cluster nodes. And finally, confirm that your applications work correctly with the upgraded cluster. So Amazon EMR, also quite simple and supported out of the box for both primary and core nodes. What you'll want to do first, though, is to go ahead and test the new environment is working properly in dev. You'll continue with some additional performance testing. That's the highly recommended first initial steps. After that, you'll want to provision a new cluster if the primary or core nodes need to be changed. You can also add or change task nodes with Graviton instances as well in this cluster. After this is finished, you'll go ahead and port your application over to the new cluster and do some additional performance testing. And there is also Graviton support available for EMR serverless, in case you were wondering that. Okay, Lambda. So if your functions don't use architecture-specific binaries, including in their dependencies, you can switch from one architecture to the other. So you can simply switch from x86-based Lambda functions to Graviton-based Lambda functions. This is often the case for many functions using interpreted languages such as Node.js and Python, or functions compiled to Java bytecode. So again, typically this will just work with Lambda managed runtimes or base images. You will want to check for JNI, shared objects, or native modules and address them as necessary. So if you have binaries in your function packages, you need to rebuild the function code for the architecture you want to use. So functions packaged as container images need to be built for the architecture, whether that's x86 or ARM, depending on what they're going to use. Okay, so let's move on to some languages in our Graviton journey. So first, Python. So Python is fully supported out of the box for most things with Graviton. Pip installs packages from PPI. These may require install time builds. AWS tracks over 200 popular packages for compatibility with Graviton at this link here. And there are Python-specific recommendations that can be found on the Graviton technical guide on GitHub. And you will definitely be using that on your journey to Graviton because it has a lot of technical nuts and bolts that you can dive into specific to your environment. Next up, PyTorch. PyTorch 2.0 Plus includes performance optimizations for AWS Graviton. Really easy to use. You can see here a little chart here with performance, different instance types using PyTorch. But again, you can see great improvement there on the Graviton platform. Next up, Node.js. So Node.js is fully supported on Linux. There's no need to recompile. Binaries are available for your favorite Linux distribution directly. Typically, the newer the version, the better for performance and compatibility. And really, Node.js just should work straight out of the box. So Ruby. Again, Ruby is fully supported on Linux. There's no need to recompile any Ruby code when porting over to Graviton. Binaries are available from your Linux distribution. AWS has actually contributed optimizations for up to 20% faster string operations when using Ruby with Graviton. And again, same rule applies. The newer the version, the better for performance and compatibility. Okay, PHP. So again, PHP is fully supported on Linux. There's again no need to recompile. You do want to use at least PHP 7.4. That's the recommended version to be on at least. We see up to 37% better performance than PHP 7.3 on Graviton. And PHP 8 includes even more optimizations, up to 8 times faster in certain engines and up to 16.5%, 6.5x faster to upper to lower operations as well. Okay, so Java. So Java is also well supported and generally performant out of the box on ARM64. Java 8 typically works well for most customers. Some customers may need to be on Java 11 or higher in order to take advantage of the full performance of Graviton. The Amazon Corretto JDK is the fastest way to get all of the performance enhancements AWS is making for Java. And Corretto 18 and OpenJDK 18 both include crypto algorithm performance improvements specific to Graviton. For C and C++, your code will need to be recompiled, right? There's no getting around that. The good news, though, is that most builds will work when run natively on Graviton-based instances. One difference is that on x86, the car symbol is signed by default, while on ARM, it's unsigned by default. And you can address this either with compile flags or with using standard integer types. With Rust, Tier 1 support is in play for ARM64 Linux, and it's generally performant out of the box on ARM64. We do recommend running at least version 1.57 or later. That enables some specific Graviton targets that are available when using that version. So with Go, Go is supported for ARM64 out of the box. It is available for all common distributions. Some popular libraries don't support ARM64 builds natively. However, if you come across any of these, please do engage with AWS, and we can support you as best as possible for your Go journey to Graviton. Okay, and .NET Core. So running on Linux is required to use AWS Graviton. That's because there are no Windows licenses available for AWS Graviton hosts. So your path to .NET is to run .NET Core on Linux for Graviton support. With that, .NET 5 brings significant performance enhancements. .NET 6 includes optimizations for JIT compilations, garbage collection, JSON processing, and others. And with this, we can see an improvement of up to 40% better price performance over current generation x86-based instances. Okay, so hopefully that was helpful in your journey to Graviton. Let's look at a few additional resources that can help with your Graviton journey and getting started. Here are a few links available. There's the AWS Graviton webpage that includes much more information about Graviton in general. There are customer references that cover many of the cases that we've talked about in this session. Also, some additional customer references you can learn about specific to their industry and workloads. There is the Graviton technical guide for level 100 to 400 level technical information on GitHub that I mentioned earlier. Highly recommend that you find that and spend some time in the technical guide because it really walks you through step by step at a very deep level of what you need to consider for each architecture as well as language and platform. There is the AWS Graviton Fast Start, which is specific to getting started with Graviton across many different AWS services. Highly recommend checking that out. There is the AWS Graviton Transition Guide, which includes step-by-step approaches for transitioning EC2 workloads. And there are AWS Graviton partners who can also help accelerate your Graviton journey. Highly recommend seeking them out as well. And then finally, your AWS account team, AWS professional services, and AWS Graviton specialists can also help you on your Graviton journey. Here are a few additional resources specifically from reInvent 2022. I have a couple of videos here that I highly recommend that you check out. One called Silicon Innovation at AWS. There's the Architecting Sustainability and Reducing Your AWS Carbon Footprint, and Sustainability and AWS Silicon, all recorded sessions from reInvent 2022 that you can spend some time on and also go deeper into the areas that we've covered here as well. So finally, just to recap as we wrap things up, let's circle back to Peter DeSantis's quote about the greenest energy being the energy we don't use, and how AWS Graviton enables customers to do more with less. So on behalf of Z and myself, thank you for listening, and we can't wait to hear about how you optimize your workloads for sustainability using AWS Graviton-based EC2 instances. Thank you and have a wonderful day.